All right, let's talk about x and y intercepts of a function. Now, the definition of an x and y intercept does not change just because now we're talking about functions. Remember, functions is a specific type of relationship, so the way we determine x and y intercepts is exactly the same. So remember, the x-intercept is where the graph of a function or of an equation or a relation intercepts the x-axis. The y-intercept is where it intercepts the y-axis. So again, to determine the x-intercept, we make y equal to 0. We solve for y equal to 0, or the function equal to 0 in this case. For the y-intercept, that occurs when x is equal to 0. Okay? So in the terms of functions, if we set the function equal to 0 and solve, that will give us what? The x-intercept. If we evaluate the function at x equals 0, that will give us the y-intercept. And so now if we're given this function here, in this example here, and we want to find the x and y-intercept, now there may be more than one x-intercept, okay? But there will be at most only one y-intercept for a function. Okay, but there might not be a y-intercept. Okay, so remember the vertical line test. So now, if we're given this function here, well, let's set it equal to 0 and find the y-intercept, or the x-intercept. Okay, so if we set it equal to 0, so f of x equal to x squared minus 4 equal to 0. And so if we solve this, we get x squared equals 4. And then we get x is equal to plus or minus the square root of 4, which equals plus or minus 2. Okay? All right, now, so that means that we have two x-intercepts. So we have when y is equal to 0, we have 2 comma 0, and we have negative 2 comma 0. So in this case we have two x-intercepts. Now, what about the y-intercept? Well, if we take f of 0, which equals 0 squared minus 4, which equals negative 4, so that means we have a y-intercept at 0 comma negative 4. So there is a y-intercept as well. Now, if we solve these and we get something that's not real, then we don't have an intercept, right? So again, just like before, okay, we have to have a real solution. All right, that's it. Practice.